starting off in Mr. Chippie's workshop on this Harvard H404, I think that one is, isn't it? It's not the 407, which would have the black speaker grill. If you can hear the washing machine on spin cycle in the background, I've actually remembered to close the door between here and the kitchen from which this room is set. Now, this is coming from a trade customer. And he wants me to do the capacitors for a start and then the retune. One of the things I think he mentioned, and I'll have to look back at his notes, this H404, is the AC/DC switch. Now, you may be aware we've been making power leads for Max onsets, or Maxcom shall we say, but we've also had some sample mouldings for the Amstrad type of lead. Now that's not the early Japan one, this is for the later Hong Kong version where you've got the square and the round, which also fits the DC on these sets, just like that, and also fits, ooh, it's all dirty now, and also fits Harvard 402 MPA, and also fits the Mustang 1000, 2000, 3000 and the Transcom GBX 4000 I think it was. Anyway, so that's what that was about. So he said the AC/DC switch is a bit the worse for wear. There's nothing I'm going to be able to do about that. I'm not going to be able to replace that, but in fact I was easily able to move it from AC to DC with a screwdriver. So if somebody needed to use it on a battery, well, it's still easily doable. You know, you can't expect these things to be perfect now they're 40 something years old, and especially when they've had a lot of wear, which this one clearly has. Right, that's got some screws in it. That's not got some screws in it. This bottom panel, which I'll show you in a moment, doesn't look original. That has been made by somebody. It's a better one than the set I've got with a non-original bottom. But it's the same metal. When you look at a genuine one, it's the same metal as this bottom, so this piece is thinner. So once I take this off, we'll know whether it's steel or whether it's aluminium. Yes, I know Americans pronounce aluminium differently. It is steel, but that's not original. So we're going to need to get under there, so I've taken it off anyway. I once bought an electric screwdriver of the cheap type. I think it was a Power Devil, and it was 2.4 volts. And even if you loosen the screws on something like this, it still wouldn't take them out. It was that weak and watery. Okay. So it's quite fiddly. It's quite a fiddly job to... Oh, that one's been done. Right. I was going to say we need to change that one. Oh, it looks like it's been done. I'll have to look carefully. Anyway, that's what needs to be done. We need to change the power supply capacitors. Pause the video. Right, so we're here on the workshop bench now. So we're going to forget about the power supply. So he overhauled it, he's done a wonderful job, and I've checked that that is how it is, which is fine. So there's something probably, for all I know, the AC DC switch there, it may be faulty, in which case it'll just have to be bypassed. But what I'm going to do, I'll run it off one of our power leads that we make and sell, and we'll run it on the bench power supply, which I often do on base stations anyway, and then we'll worry about the internal power supply when the set's finished. Nearly put it in the wrong way around, not that you could do. So that clips into position, we're on the DC position there, and we need to have the instruments plugged into the extension speaker. We'll get that connected to our power supply. I've already seen it light up from our power supply in the other room. Right, switch the power supply on. Straight to 13.8 volts. Switch the radio on. And we're lit up. Channel 20 it is. So he didn't send a mic with it, that's absolutely fine. I did just email him in case he did and it's gone astray. Right, so I've got the standard test mic here, and the first thing of course we'll do is the VCO. So just a quick check, I'll put picture in picture on, and it's transmitting, it's doing 3 watts. So, VCO. As ever, I'll have to get the info out. So it's a SINAD 002 F chassis. It's also used in the Amstrad, and I've got the manual here for the Amstrad. So we want a test meter, and now I'll put it in a silly place somewhere. We'll put that on the power supply, since we're not using the power supply, and we'll need one of Mr. Chippie's crocodile clip leads. I think I've lost them all. Why have I lost all Mr. Chippie's crocodile clip leads? Well, we'll borrow that yellow one. You know what? It's probably negative chassis for all I know. Let's just find out. Yeah, it's negative chassis. So it's the far side of this capacitor. Go to channel 1, and we need to be in receive, and it should be 2 volts. So we just T1. T1 is there. Let's pop that back up a bit. So 2 volts on channel 1. So we're now going to transmit, and we should have 2 volts on transmit. We've got 2.4 for just a trimmer capacitor for 2. So the VCO is probably one of the most important on this chassis, because it can drift with temperature. So back to receive, 2 volts, back to transmit, 2 volts. Then we go to channel 40 and check it somewhere around 4.5. But it's never going to be 4.5, and that's a false reading. So it needs to be under 4, to be honest. So we've got, the point is the VCO is locked, and there we are. So don't take the 4.5 volts bit to heed, it really needs to be around 4. Good, so that's set that. probably did it with an Avo 8, you see. Right. So that's the important thing. So back to channel 20. Tune it in the centre of the channel, centre of the band. We're going to go up there, there, and there. So with picture-in-picture on, make sure it's at peak. So I'm virtually at full scale, as you can see, but it is easier to see those little tiny differences. That's peak. We could change the ballast resistor value if we don't get 4 watts. Or dropper resistor, whatever you want to call it. If that's ever missing, and there's all this silliness, especially on the internet, that you can take that out and it'll do a zillion watts and you can contact space with it and all that kind of stuff. It doesn't actually do it doesn't do more than 4 watts on 27 megs. It does all those extra watts. There we are, 4 watts. It does all those extra watts on aircraft band. So just make sure that we've got peak there again, because they are interactive to some extent. It's going down. Absolutely spot on. Just melt the wax back into position. So I think it's 3.7 ohms, something like that. I think we've had them down to 1.8 of that, but it does need to have a resistor there. The 2SC2166 is so difficult to come by that expect to pay £16 for one, usually from America. AliExpress and eBay will sell you 2166s for pence, but they're always fake. So they're probably tip 41 audio transistors rebadged. So if I look at the number on that, see it's painted on. They stopped making those transistors about 20 years ago. So they're not laser etched. So when you see them with beautiful shiny leads for sale and laser etched, well, they're fake. So, and I've done all these demonstrations before. So we've got 4 watts. I can check low power, which is the button at the back. It's supposed to be 0.4 watt. It's not adjustable if it isn't. It's 0.3. That's absolutely fine. It's useful to have low power. And it's a shame not that when 2781 was replaced with the other specifications, then it was no longer a requirement to have low power. And that is a shame. You can be in a convoy of cars and blowing each other's windows out because you're all waiting at the traffic lights. And in actual fact, if you've got low power, it would be much easier because not all CB radios have RF gain to cope with that amount of signal. So, let's have a look at what the meter reads. If I can actually move it upwards so you can see. So key it up, and it should be in the centre of the red zone, and it's swinging right across. It's easy to do this without showing it the camera. There we are, centre of the red zone. Now, when I do an on-the-air test with this later, we know that into out dummy load it's set in the centre of the red zone. But when I do my test and put it on an aerial, it may be hardly moving, it may be banging across, and I don't want you to ever think you're doing more or less power because the meter is relative to SWR. These days, modern sets, the meters are pre-programmed just to read nothing actually more than what a TX light does. So you can take the output transistor out of modern sets and it'll still swing across because it doesn't mean anything. It's just pre-programmed and just comes from the CPU. So it's a BS meter. But on these it's relative, and at least it proves that the thing is transmitting. So, next thing is deviation. So let's see how loud it is. Wow, too loud, it's 3.5. So you don't become louder, you become wider if you set the deviation too high. So only on something like a Fidelity 1000 will you sound louder. Wow, that's now spot on. So it should be an average of 2.2 with an absolute peak of 2.5. So there we are, that's transmit. Oh, I haven't done frequency, have I? So let's put the camera on, or put the camera on for the frequency counter. So it should be 27.79125. It's 27.79101. So it's not out of spec. Some of these aren't coming up these days now, they're 40 years old, and it means changing the reference crystal which is there. So it's anti-clockwise for higher frequency. And the other thing you come across is broken cores. So I'll just unkey because that isn't the right tool. Why haven't I got the right tool? It's that one. I'm praying it isn't broken. 27.791 0304. So it won't quite go, it's 79113. So it's neither here nor there, it's not off frequency and it's well within spec. So anything really above 085, but now it's come to this time that these sets are, we're not wanting to change the crystal. It means trying to find one out of a scrap set, because the new crystals, to have them specially ordered, 30 odd quid, and I found that none of the cheap Chinese ones are anywhere near what they say on the tin. I have bought 24 cheap Chinese crystals, and I think we were able to use one. So we're still at the, you know, if you're paying £1 each, you're still back to the £30 by the time you've done that. Which is a shame. So that's fine. Receive. So we're going to set the signal generator to 27.79113 so that I'm tuning the receiver to what the radio is actually really on. And then when it's off the test set, it'll be spot on. If I turned it to 79125, although it's neither here nor there, it could be just slightly lopsided. Now the first thing I've noticed, I've got no receive hiss. So the squelch preset is way too high. I think it's that one. I'm right, it's that one. We'll come back to that. It's a bit of a wishy-washy squelch on these. They don't squelch out as high as I would like, they don't work as well as I would like. And I think people just turn them up too far. As often with these, when they are set right, if you don't have an aerial plugged in, it will still be muted. So if you're testing one of these sets, you plug it in, plug the mic in, turn the squelch down, there's no hiss. You do need often to put a bit of an aerial on for it to do anything. These LA 1230 FM subsystem ICs were intended for stereo FM hi-fi tuners, and they have the squelch, which you would call mute in the hi-fi parlance. So, well, I'll put the SINAD meter on, we'll put the oscilloscope on, and see what it's reading straight away. Let's put it onto there for you. No idea why this isn't in camera. I've set these up. It really doesn't matter. It's very good, this. It's already 0.42 microvolts. for 12 decibel SINAD, so it's excellent. So what we'll just do is we're going to put the oscilloscope on, and that one wants moving too. I think we've got poltergeist in here. I don't need it in the middle. Right, just pop the bench lights off so you can see that a bit better, and we'll just do the detector, which I recall is that one there. Wow, I was just putting a hefty signal on of S9. That was absolutely miles out. So everybody would have been quiet and garbled. Right, now we'll put the SINAD meter back on. Missed it. So as ever, we want that to about 4 dB so that the receiver's not being saturated. No improvement there. I think it's probably very well set up with it being so sensitive, apart from that detector. Very slight improvement there. No improvement there. We'll just run through these IFs. Need a bit more signal for that. Slight improvement there. No improvement there. Now this is going to be interesting, because now we're going to see what the SINAD is. Now that I've tuned that, and now that the detector's right. I wonder if it'll be worse. No, it's not. It's not. So for 12 dB SINAD, if we go over to the attenuator controls, we're at 0.38. So it's working very well, 0.38 microvolts for 12 decibel SINAD. So we're going to put this now to S9 and make sure the meter reads S9. So for a CB radio in the UK, it should be 100 microvolts. Not to be confused with S9 for ham radio, which is something like 0.56 microvolts. We're not talking about ham radio, we're talking about CB radio in the UK. So that's pegging the needle. I need to pop that down a fraction. There we go, that's S9. Good. Well, I think we've done everything. So the next thing we're going to do, I'm going to come back to this probably tomorrow. I can only do 40-minute sessions with the organ job as well. So we'll turn some of the test gear off. I might be able to do some to this later. My next thing is I'm going to look into why the power supply isn't coming through to the radio. Or maybe it is and it was just a switch not in the right position. I'll tell you what, I'm going to unplug our 12 volts. There you go. So that's tested that power lead, hasn't it? So when somebody orders that, we know it works. I'll put that back to AC. And I'll just see whether we've got a spare sprocket. We can unplug the power supply, we're not using that anymore. Got an extension socket down here. So he's absolutely right, we don't have anything coming out of there, so just put the meter on it. Just a switch, isn't it? There you go. So he's set the power supply up right, he's done the overhaul work on that spot on. So I'll get that unsoldered. I'll get Mr. Chippie to dismantle it, because there's a possibility that, I know that the thing's broken off the back, but it'd be better to have that than just to link it out. So that's all that's wrong, is the switch. I've never seen that before. They must have really bagged in it to do that, surely. Right, I'll pause the video and get that switch removed. So the same day, Mr. Chippie has kindly taken the switch apart, and now it's running on its mains power supply under its own steam. So I'm just curious as to what power it's doing on its own power supply, bearing in mind that the internal power supply is set to 13.8 and the external power supply was also 13.8. Of course the set's cooled down. Let's plug the mic in. Let's key it up. Yeah, it's 4.3 at the moment, but that will soon drop. So that's within. Right, there we go. Excellent. I've checked it on PA. I don't think I did that with the recording going, so we'll just show you it on PA. Testing 1 2 3 4 5 5 4 3 2 1, and bizarrely it's the volume control which affects it, not the mic gain control. There's always some difference, isn't there? So we'll go back to CB. I'll take the signal generator. I'll actually switch it off, and with no signal we've got a hiss, which I say you can end up with it muting. I'm going to turn the squelch on. I've just had to put the test set back on because we hadn't actually done the squelch test. If you remember, when I found that the squelch wasn't opening at all, I just roughly set it so that it did open. And as it happens, I'm spot on. So we'll put the signal generator, because I'm going to have to open it up if it was wrong. There's no messing about. I'll just put the other camera on so you can see the attenuator controls. So what I wanted, I've got the radio squelch on full. So at the moment we've got 10 microvolts, 30 microvolts, 100 microvolts is when I want it to open, which it does. So then let's go down the opposite way, turn the signal generator to standby. So it's parked at 0.3 of a microvolt. Turn the squelch down on the radio. Set threshold. Switch the signal generator back on. Straight in at 0.3 of a microvolt. So it's coming at 0.3 of a microvolt. It's actually tracking right down to 0.1 of a microvolt. So it's very sensitive squelch, and yet it's strong enough to open at S9 if we want it to. So I'm glad I didn't have to open a setup, and it was right. So that's another good point. It's now frequency-wise. If you remember, we set it, the highest it would go was 27.79.113, and now the set's warmed up, and yeah, we're still at 113. So it's absolutely as good as we're going to get on that. It's not going to go up without changing the crystal, and I say that really doesn't matter. It's not off frequency. People think you need about 10 decimal points after the 0.25. You don't. There's more tolerance than you think. So I'll turn the signal generator off once again, and we will plug it into the aerial, and then we'll do an on-the-air test. Anyway, I'm glad Mr. Chippie was able to fix the switch. He's good at dismantling switches and cleaning the contacts and putting all the little springs back together. But I didn't want to bypass it. I know the toggles come off the switch, but you can move it with a screwdriver, but it means that the radio can still be used on 12 volts if you want it to. So we're on an aerial now. So RF gain up, squelch down, 19, 19 Roger. Some, you know, we get.
Yeah, he's on about 4 o'clock every day.
So he'll be 30 odd miles away at Nottingham, and no doubt not on 4 watts.
I should soon know. I have to sort of turn it on until it's come alive, and I know it's working.
That's a sensible conversation. Right, so there we are, Harvard H404 from about 1982. The 407 seemed to come first, and they were in the 129 to 159.99 type of bracket. So the work the dealer who supplied this has done to the power supply, if you saw it, you know, right at the beginning when I was in Mr. Chippie's workshop, that was spot on. And that the quality of that work's a credit to him. So apart from the deviation being a little bit high and the power being about 2.9 watts as presented, the set has come up a treat. So you can see it's had a hard life. It's bashed around a bit on the front, and he's painted that up nicely, but at the end of the day it's a 40-year-old radio, and it works, and it lives to work again for somebody else, so that can go back. So thanks for watching, and we'll be having the on-the-air test later on today.